Okay, so before 1920, okay, the student will be, the class will be Monday through Friday. Six hours a day. So the total hour one semester you get 18 weeks. Okay, time. 1 day, 6 hours. 1 week will be 30 hours. So you get 540 hours. So you get one semester, you get total 540 hours maximum. So basically you need only 2 semesters, you can meet the requirement of the city for 900 hours. Okay? See what happened now. Now, okay? The total hour. One semester. They given you only 252. You see that? This time I cannot control the hour. They set it up that way. No matter what, 250 hours. So look like before you can get a certificate for 1 year. And now, if we're using the total of 900 hours, take you at least 2 years. Okay. So basically, you this situation. Your certificate. Depend on one lecture. That includes assignment. Okay, quiz. Lab. Quiz and find and test. Second thing. Level. the lab. Okay, so basically, you have to get the lecture be done. If you've already done last semester, and now I don't care. You don't have to do any assignment for Tech 1 at the spring. However, on the left one, you already done it. However, last semester or before, or when we start 2020, we don't have any more lab. They close. Now they just give it to you last fall, and this will be spring. So any lab one you're not done, then you try to get it done. And also, that given you guys a very hard time. Also, in this semester, you also get a digital lab, the lab. We don't care about the hour. The thing is, when the student complained, he said when he get into the lab, he have to sign the paper, but not the time in or time out. That means the time for the lab. The reason why you have to sign, the thing that I want to make sure you already get a valid COVID-19 done. Okay? If I recording the hour, and basically the hour, it means nothing. You can get a 500 hours in the lab, but you're not done on the lab. What can we do? We're not based on the hour. We're based on your job. Everything you do in the program, lab won't be recording in the server. And they know how much you'll be done. Okay? They think that they have to report it to me. And also for the digital lab, the lab, they also have to be reported. In order, I prepare for the certificate. So never asking me how many hours you get in the lab. I said, I don't care. You can get 300, 400, 500 hours, but we don't care that hour. We care about how much you'll be done. Okay? If you're not done, go ahead and do it. That is the key point. So any question, anything regarding into this situation right now in this program?
Is there going to be a summer semester?
For sure. Keep running. The thing is, you see that I still running the program, and the program keep running. Only thing, if I retire, and maybe the program still running, but maybe cannot get more students. The thing is, I don't think that anyone can spend too much hour and get paid less. Before 2020, instructor almost get 15 hours teaching for a week. So that's why you get more day for the lab. And now they given only 12.5 hours for a week. So that's why 3-day lab, 8 days, 4 hours. That's the 12 hours.
Mr. Fan.
They treat this program like the other ESL class. I already let them know. They have to understand this is a program, technical program, not only teaching. We get too many things must be doing in the program to the program keep running. Something going wrong. Level not working. Circuit board not working. Everything, computer. Who fix it? We have to do it. No one happy. No one from the CD can help it. Even they don't know what to do. If some computer dies, if we not fix it, they can send the people to help. However, take about a month, 3 weeks to a month to fix the problem. So the program cannot run. If we don't have a computer working, how come they can do the lab? That's why on instructor, we are engineer. Whatever they can do, we can do. This program has been running for over 36 years, and we're doing much better. Okay, so what I recommend to you, take you, if you want to get a certificate, I only want you to get either level and also the lab done. We can do more favor. For example, level you can up to 70%. I say, okay, it should be okay. And the D lab, if you already know how to do it, I believe will be done quick. Especially for the D lab. If you get a problem with your software, a problem with your hardware, you can text to me. I can on Zoom with you, just about 30 minutes. That can, everything can be done. The others, you know, in the program, maybe they not get along with the lab, so take it more time. However, I the one design it, so anything I can get you done about 30 minutes. Okay. Okay, any question? If it's not,
Did they reduce the hours because of student count, or student count doesn't matter?
what? Can you say again?
The hour reduction, that wasn't determined by how many students, right?
Yeah, the hour they're telling you how many students. See, they need that hour. If we not meet the requirement, they close. It's not like college, not like university. University, they teaching no matter what, how many students, doesn't matter.
That's not totally true, Mr. Pham. I know what you're saying, though. all the colleges and continuing education, each class have to have a certain amount of students. And if they don't, then they'll close the class.
That the university or the college, city college,
Right.
okay? But the
Okay.
requirement, you see that, take about 15 students or less, maybe they cancel, maybe. However, the requirement for the continuing, they require instructor, one instructor, you have to get 25 students.
Right.
When I start this program, they require 12 students, okay. And they keep going up. 12, go to 14, go to 18, go to 24, and now it's 25. If you less than 20, they close. At this time, they drop on not the student, not through the COVID-19. So that's why the number of students going down. Okay. However, they cannot grow. They have to working on that. They don't have a student anyway. Not this class, any class. The thing is, why we open lab, but not much student get into the lab right now. The thing is, even they already get the COVID-19, okay, done. However, they still not want to go into the class at the time. That doesn't matter to me.
Regardless of the shields and the separation, space differences of the students.
You mean the seal?
There was always a requirement to improve student space. So there's just contradictions, is all I'm saying.
I don't know. But the thing is, they will be changed. They have to change it. Doesn't make sense. The people just want online. How come they drop it? Is it they forcing anyone must be take the COVID-19? I don't care. I don't want to think about that. Okay, any more? Okay, make sure if you get problem doing the lab, then you can just talk to me. I can help you out. That will be a good time to get a certificate in this year. Okay, so normally the process for the D-Lab, you have to done for Excel. Make sure it passed. You have to get your test program software done. Copy into Excel and upload. Sam will be check your software to let you know software pass or fail. If it failed, then you have to fix your software. If it passed, you can build a circuitry. Okay? And you have to run for the lab instructor to verify you complete that lab. That means pass with the hardware. That is the process we're doing at this time.
Fan.
Yeah.
Is that possible to make lab 1 and lab 2 at the same time?
That's what I said. You can build lab 1 and lab 2 in the same board. And you can verify both at the same time. Let's save the time. Did that answer your question?
Yeah, because I don't finish my lab 1, but I would like to start the lab 2.
Anyway, you have to get the done lab 1 anyway. Cannot be skipped. You can say you do lab 2. Okay, okay. But you still own a lab 1. Okay, any more questions? Otherwise, Sam, to get anything?
No, look like you got covered most of them, everything. Look like I did. And now, if you have your, I think I have most of your guys' email, so that way, if the lab fail, I can email you with the result right away, so that way you can continue working, because like even you work on the weekend, and if you can keep on working and upload that, and then I can email you the result, and then so that way you can fix your program and then re-upload it to the website and can recheck it. So that's why we can get it done quicker. Okay, so make sure that if I don't have your contact or your email, just put it on the Excel, and so that way I can always and then I will able to contact you. And if I already have your email contact, so that's good, and I will email you with the result. Okay.
Thank you, Sam.
You're welcome. Thank you.
Any more question? Anything? Okay, if it's not, wait for me. I can get into my iPad. Okay, so today we're talking about latch and flip-flop. Okay, before we start it, I want to ask you. Okay, can you tell me what the output expression for this is a NAND gate? Y equal what?
Is it A times B with that underline over it?
Okay, that means you're talking about
A times B, and then put that line over it. I can't remember what it's called, but I'm pretty sure that's the right equation. Not, that's right, not
A and B. Okay, but they have to be equal. The Morgan law. equal what?
Not A or not B.
Exactly. Not A. Oh. That means they're converting product into the sum. A become not A. B become not B. N become O. This is the equation easy to get the output. Normally, you can see you can get the truth table. You can open the truth table telling you what A equal, what B equal, what Y equal. Okay. However, I don't care about that. I really care when you get the input, you must know what the output's supposed to be. Now, if I get a 0 here, what the output equal?
You don't know.
Come on. If A equal 0, what output equal?
Oh,
One.
oh, it'd be 1, right?
1, yeah.
Okay. Now,
Oh.
A0 not A will be equal
1,
or would not be. Is that right?
yeah.
Equal what?
Would not be 1 plus 1 equal 1.
1.
Correct?
Right.
You understand the 1 or A or B or C or D or whatever, they must be equal 1. In a digital 1 means you connect it to 5 volt. Okay, now A0, then output of the NAND gate must be 1. What happened to B?
Don't care.
Okay.
That exactly. B
Okay.
have to be don't
Care.
Okay.
care. Now,
Okay.
what that mean for don't care?
B can be 1 or B can be 0. You don't care.
Exactly. When we say don't care, that means they can be 0 or they can be 1. Doesn't matter. Correct?
Correct.
Yes.
That's
So now, you learn on Tech Cube. You learn troubleshooting. But I telling you what? When you start doing your lab, you build it. Build one time. Then you run the test. Okay? If it pass, very good. However, if it fail, your job will be try to fix it, not try to remove all of the wire and try to reconnect it.
In other words, you don't want people to rebuild it. You want them to troubleshoot it.
Exactly. You try to find out what's wrong and how can we do to fix the problem. That's what the thing you have to do in the company. In the company, the board already built it. You cannot remove anything. But you have to find out what caused the problem. Okay. So now, on this one, if you measure the output, supposed to be logic 1. However, you measure 1.5 volt. we're talking about DC voltage, okay? Then you know it's wrong. So they will be wrong. So normally troubleshooting, when you get the output wrong, only thing is you have to check the input, okay? If the input is right and you cannot get the output, then change the part. Okay. So now if you measure the output, you get 1.5 volt. They're not 1, they're not 0. Then what can you do?
You have to troubleshoot because 1.5.
I agree, but you're telling me you want to measure where, what you wanted. The thing is now you're using a meter or the oscilloscope. You measure the output, you get 1.5 volt. You know it's wrong.
You have to measure the input.
Yeah, measure
I
the-
agree. Go detail for me. What input? What you want?
Well, you're probably gonna have to measure A, I assume.
Exactly. You
Okay.
want to measure A here. Okay. And if you get 3 volt, now you get 0. Sorry. Okay. You measure, you get 0.2 volt. What next?
change the part.
Okay, Mr. Smith said change the part. Oh yeah,
Because you got a logic 0 and you got the right input, but the wrong output. And B, you don't care. So then, yeah, you just got to change the part.
yeah, that's correct. Okay, why we don't need to measure B? The thing is, you said the B don't care.
Don't care.
So that's why they can be easy. They can be 0 or 1, doesn't matter. The output will be a 1 when the input A must be 0 and you get a 0. Okay, so that's why you just change the part. But you cannot say I measure A then I measure B. Okay, that means you not understand. Sometimes supervisor asking you why you change this part, then you have to prove. You can say, okay, I measure the output is 1.5 volt. This is not get a right output. It's supposed to be 2.5, 3 volt, 4 volt, 5 volt. And when I take the input A, I get the 0.2 volt. So that's why this part is not working. Don't say you measure B, you can get a problem. The thing is we say B don't care why we measure it. This is digital. That have to be very, very logic. Okay. You cannot say you can measure B, okay, it didn't hurt anything. But they're telling the people do not understand it. Okay, that we're talking about end gate. And now, if I change the logic here, okay, okay, and I can get 3 volt. And I measure the output, they will be 4 volt. So it's wrong or right? When I apply, I know A equals 3 volt. I measure output, I get 4 volt.
You have the right input, but the wrong output.
Why you say right? You want output to be 0.
Right. But it's not 0, it's 1.
Exactly. 1. 0. However, they measure 4 volt.
And 4 volt is logic 1.
Right, so wrong.
So it's wrong.
Okay. So it is wrong, and you have to take A. Right?
You have to make sure A is a logic logic 1. Because A is 3 volts, and 3 volts is logic 1.
Okay. Then now you have to take the B. Right?
Right?
Okay. The thing is A logic 1, not A equal 0. B logic 1, not B equal 0. 0 or 0, you get 0. Okay? So if you get A 3 volt, B 2.5 volt, and the output is 4 volt, so you know the part is not working. That is troubleshooting. You get wrong output. You must be check the input, make sure they get the right input. If they get the wrong input, you have to go back again. Keep go back until you find a problem. Okay. Now, another gate we also need you to know. What y equal? Okay, again, A, look like we don't have that bubble here. No bubble. No bubble here. So you get or gate, A or B. Okay, that without the bubble, just the OR gate, A or B. When you get a bubble here, mean not A or B. Okay, not A or B. Convert to the product. What you get? A will be not A. R will be
And
N. B will be not B. This is a formula you need it. Using this formula, you can find out output right away. For example, if you get an input logic 1, what output supposed to be?
0.
0. The thing is 1, not 1 equal 0. And with not B, anything and with 0 must be 0. They're telling you this input will be down.
True.
Okay. That is the key point. Okay. Now we go. The large is the type of temporary storage device that has two stable states. That's what they call a bistable. They can be either 0 or 1. And it normally placed in category separate from that of the flip-flop. Large are similar to flip-flop because they are bistable device. That means they can get either 0 or 1. That can reside in either of two states using feedback arrangement, in which the output are connected back to the opposite input. The main difference between the large and flip-flop is in the method used for changing their state. Basically, they still just a flip-flop, but a different. Okay, first thing we learn, SR flip-flop, set, reset. Okay, large. A large is a type of bistable logic device. Okay, a multi-vibrator. An active high input SR. Large is formed with two cross couple NOR gate. Now you can see this guy here. Okay, this is the NAND. Okay, the NAND set reset latch of flip-flop. This is the NOR. That means this is using AND gate to build. This is using NOR gate to build. Okay, and also this is a symbol. Symbol means instead they draw this one, they draw this one, same thing. And they say active low, active low. Okay. Now we need to know set or reset. What that means, set. Set the flip-flop. Mean what? Who knows? If I said set the flip-flop, how much you understand?
Put the output in 1.
Q equal to what? Mean Q, output Q. Okay. And if I say reset, or sometimes they're using clear.
0.
Flip-flop, mean Q equal 0. That's what you must know when you learn digital. When I say that flip-flop is set, then you have to understand that Q equal 1. However, if I say that flip-flop is clear, then Q must be 0. Okay, so if you get any questions, just let me know. Okay, otherwise we keep moving and you get lost. Now,
Hey, Mr. Pham, one quick question.
yeah,
So this is like at the very beginning of class where we said set is the same as pre and reset same as clear. So it's set as 1 no matter what. And then clear is 0 no matter what, because of what the inputs were.
Then the thing at the beginning, they say, okay, the flip-flop are set. Then you must be understand the Q of the out of the flip-flop will be equal 1.
Right.
Or they say at the beginning, the output of the flip-flop is clear. Then just telling you Q will be equal 0.
Okay, thank you.
Okay, another thing you also have to be understand active. When you see the bubble right here, that telling you they will be active low. Okay, and now you see in here, no bubble. They will be active high. Okay, now, what happened for active low?
It's 0.
That will be telling you that if you get a 0 here, okay, that means you want to set. That means if you get a 0 here, Q have to be equal
1.
1. Active low. That means the 0 you want set. However, reset here. If you get a 0, means you want to
Reset.
reset. And reset means Q equal 0.
0.
Okay? However, now, if you get 1 and 1, then what?
Zero, zero?
No.
Q equals 0.
Set equal 1, they not active, right? They active low.
No,
Reset the same. However, if both equal 1, nothing happen. That's it. Nothing happen. Cannot tell what Q equal. Okay? And also on the flip-flop, they will be get Q output. Okay? Q and not Q. Okay. If Q equal 1, then not Q must be 0. Or if Q equal 0, then not Q must be 1. If it's not, they're not working like the flip-flop. Okay? So, when you're looking into this slide here, I really want to understand the set or reset flip-flop using the NAND gate or NOR gate. Okay? And also, okay, also you have to know this is a symbol. This is a logic circuitry. This logic circuitry inside this one. Okay? Same thing. This is a logic circuit. and this a symbol. This will be inside the other one. And also active low, okay, or active high. Now, they given you one for NAND, FLIPFLOP, and NOR. I talking about NAND first. First thing, when you're looking at the input, you get the S and R. Two input, automatically you get 4 combination. 0, 0, 1, 1, 0, 1, 0, 1. And now we need to calculate the output Q. Okay, for each combination. First thing, you're looking into SR equal 0, 0. Okay, S not equal 0, S is 0, what Q? I 0, what not Q? We're talking about Q first. S equal 0, what Q? You understand the formula? Q equal not at or not at or that one. Okay, not Q. Okay, so we don't need that. Now you're just telling me. We already explained to you. S equal 0, what Q? When you get S equal 0, what Q? You understand another input right here. That is a feedback. Feedback, what that means? That from this output go back to this input. Okay? That is a feedback. Connect from output back to the input. So my question here, if I get S equal 0, can you tell me what Q?
One.
1. Okay. Now, Q, you said Q equal 1. What happened to that one?
Depend of the previous situation.
I want
It depends on what R is, what not R is, right?
Q equal not at, right?
Right.
Or with feedback. So I already telling you, I given you S equal 0 and someone told me the output must be 1. My question is, so what happened to this input here? What happened?
It has to be low. 0.
I already telling you right here.
1.
Don't care.
Don't care. That's what I read. You must be say don't care. Correct? For the NAND, One input, zero output must be 1. You don't care about the other one. If you're confusing or do not quite follow it, let me know. Okay. And now, if R equals 0, what not give?
0. Not Q is equal to 0. Oh, I'm sorry. If R is 0, is that what you said?
R equals 0. What not give equal? Just an AND gate.
0.
Same.
Not possible.
On a NAND gate, if you have 2 inputs of 0, your output is going to be 1, that would be Q. Q would be 1, and then not Q would be 0.
Now the thing is, right now I'm not talking about the flip-flop. I'm
follow.
talking about the 2 NAND gate. If you get a NAND S equals 0, you say Q must be 1. You don't care about this one.
If R is 0, then not Q is 1.
Exactly. That's what I wanted. You see that? And this we don't care. The thing is, the NAND gate, 1 input equals 0, output must be 1. You get that? So now, if you get a Q equals 1 and not Q equals 1, they're not working like the flip-flop. The flip-flop means Q and not Q must be opposite. Q equals 0, then not Q equals 1. Or Q equals to 1, not Q have to be 0. So that's why in the truth table, they say not allowed. Okay, try to understand what they mean not allowed. Who can answer that for me?
It's like pre and clear. They both can't be 0 at the same time.
Yeah, but they say not allowed. How much you understand not allowed? I understand they not allowed S equals 0, R equals 0, right?
Right.
That's only telling you one thing. Never connect S to 0 and R to 0. They not allow you to do it. The thing is, they're not working like the flip-flop anymore. You get that? Okay, now we go to the next. Okay, at 0. I go with the truth table. I equals 1. See what happened. S equals 0. What give?
1.
Right?
It's 1.
Okay, 1 and go back here. You get 1 and 1, not give equal.
No change.
Come on. Name get
0.
0, right?
So 1 to give you 0.
1 and 1. You get a 0. And this 0 fit it back here. 0, 0, you still get 1. So that's correct. Output Q 1, then not Q be 0. So that's why you're looking into the truth table here. If you get S0, R equals 1, then Q equals 1, and not Q equals 0. If you're not quite really understanding, however, if you're looking in the truth table is telling you what the output is supposed to be. Okay, now I go to the next one. Next one is S equal 1. I equal 0. Okay. What Q equal, what not Q equal?
Q equals 0, not Q equal 1.
Okay. Now, 0 here. This is the name. Right?
Mhm.
No
Oh.
matter what, Q must, not Q must be what? That's
Right.
what I know. On up here, I get a 1 in here. I cannot tell what Q until I know what here. However, I0, I know for sure. Q not Q must be 1. Okay? And 1 here going back. 1.
So a 1 and a 1
1.
is 0.
0.
And 0 going back. 0, 0, you still get 1. So that's why S equal 1, I equal 0, then Q equal 0, and not Q equal 1.
Yes.
They just prove it for you. How come you get Q equal 1, not Q is 0, or Q equal 0, not Q equal 1? Try to understand one for the name, easy to understand the norm. Okay, the last one. The last one is 1 and 1.
1. Not chain, not around.
1 and 1. First thing, S equal 1, what Q?
Equal 1. Q equal
You don't know.
no.
Depend on the previous.
Depend on the feedback, right?
Yes.
But you don't know feedback, then you cannot tell Q. Also, I equal 1, and also depend on the feedback right here. You don't know. You cannot say not Q equal. Okay? So now, if looking into the truth table, they say no
No.
chain. Now, what does mean for no chain?
Whatever the last output was.
Exactly. Whatever at the output Q, if they equal 1, that means they still be 1. If they 0, that means they still 0. That means no chain. Okay? So when you get the input S and R equal to 1, that only telling you if previous Q equal 1, now they will still be 1. That means no chain. If previously they 0, now they still 0. Okay? And that will be applied for also the norm. Okay? And you can see the same way. But in order to know the output, Q and not Q, they given you the truth table. You're looking at S and R at the truth table. They will be telling you what output Q and output not Q. Okay? Two things. If they say no chain, that means it equals 1. Now they still be 1. If it was 0, now they still be 0. Okay? Not allowed. That means you never connect S and R to that logic. Like, for NAND flip-flop, you never connect S to 0, R to 0. They not allow you to do it.
Question, Mr. Pam.
Yeah.
Question. On the circuit to the left where you got the NAND gates, if one of those inputs is 0, then you know you're going to have an output of 1, correct?
Yeah, that is any input here 0. Output have to be 1.
Okay. Now, on the other one, on the right side,
Opposite.
it's the opposite. If you have a 1, then the output would have to be a 0.
Right.
Okay. All right. And would that be the way to attack it? You look for, on the NAND gate, you look to see if you have a 0 on the input, then you know you have a 1 on the output. And then on the what is it, the NOR gate, you look to see if you have a 1 on the input, the output 0. I guess I'm trying to find out a way of attacking it.
Okay. That is just opposite. Okay. Only thing is, you have to learn how to look into the truth table in order telling you what the output. Okay. For S and R input, you're able to tell what output. Try to understand what they said, no change. No change means if it was 1, now they still be 1. Nothing changed at all. If it was 0, now they still be 0. And also you have to understand not allowed. Not allowed means they not allow you to connect S and R to that logic. For example, on the NOR, they not allow you to connect S to 1, R to 1. That never happened. Okay, quickly for a few minutes, try to draw output for me on this one to see how many students able to understand. If the SNR waveform is so below, apply to the input of the last NAND. Okay, determine the waveform that will be observed on the Q output. Assume Q is initially low. If you can draw right away, that means you really understand it. Just a few minutes, okay? If you already download that one into your computer, and now you complete drawing, I can let you share. If it's not, I can draw for you. I can say this is T0 at the beginning. This is the T1, T2, 3. Okay, at T0, what Q equal?
0. Starts at 0.
0.
0. Yeah.
Why?
Because it says it's initially low.
Perfect. You see that? They say right here. So I know they will be low. Okay. And the next one. That will be 0, right? That will be 1.
It means the output goes to 1.
Q1, yeah.
You can say I can need to that one. Okay. So at 0, add 1. What Q?
It's high, it's 1, right? It goes from 0 to 1.
1, yeah, 1.
They will be 1. Why they will be 1?
Because on the truth table, S is S is 0, R is 1.
Because there's no change.
Not yet, not yet. I'm
Not yet.
talking about from here to here.
Yeah,
Okay.
you look at your truth table and S is 0 and R is 1.
Right here.
Next one.
Right. Exactly.
At 0, R1, Q1. Now, on this part right here, 1
1,
and 1.
1 and 1.
1.
Still 1.
No change.
The output is still
No
1.
change.
No change.
That means it was 1. Now they still be
So 1.
1. Okay. So the next one,
0.
Okay.
it is 0 here.
You reset 0.
It reset, yeah, it resets it. So it goes to 0.
0,
0, 1
and
will give you a 0. That give you a 0.
okay. At 0,
S is 1, R
at
is
1,
0.
R0.
So you
So
get
it
Q is
resets it to
0.
0.
The 0, basically the 0 up to here, right?
Yeah.
And a little more here, 1 and 1. They will be
Continue 0.
no change. No change, right?
1 and 1 is
The
no
same.
change.
No change. Yeah.
Okay. And now from here, 0 here,
1.
1 here, go to 1.
Go to 1. Yeah.
Man. Okay, they will be 1 up to here. And now you can get this one here. 1,
1 and 1, no change.
no change, they keep 1. Okay, and from here, you go back to 0, right?
0. Yeah. Reset.
0, and this part here, 1, 1, they no change. They will be 0 here.
No change.
Okay, and this way 1 and 0, they still be 0, right?
Yeah. 0. Reset.
Man. Okay, and this will be up here, they still be 0, right?
1. 0.
Up here, there will be no change, they still be 0.
Yeah. No change.
Okay, then now they go up to 1.
Yeah.
Yeah. It sets it.
Reset.
Yeah.
And this DV11 no change.
No change.
All the way across.
Okay. 0, 1. They still be
It's all the way across. It's gonna be 1.
1
Mm.
and no change.
Exactly.
That's how this signal look like. Okay, now try to get this done quickly. The thing is, make sure you want to do lab, you want to understand, then you have to be in the lecture, okay? Without the lecture, you cannot understand. Only thing is you already know how they working before to me. Draw cue. Output waveform for given S R flip-flop. They given you S and R. Okay, and this is the active high. So basically inside the simple just NOR. Okay, NOR flip-flop. And this is the truth table I gave it to you. You can looking into the truth table and you decide what cue.
For the first one, Q is 0.
First one cue will be equal 0.
0.
Okay, if you get a question, just bring it up.
Zero, 0 is no change, is the next one.
Right. S equal 0. Okay, you can see the truth table right here. S equal 0. Q equal 0.
Yes, 0,
Okay.
0, 0 is no change.
And 0, 0 will be no change. No change, that will be telling you they keep 0. And the next one, 0,
0,
1.
0, 1. Is output is 1.
One,
Output is 1. This is 0 here, 1 here. Output equal 1. Okay. Okay. And 0, 0 will be no
change.
No change. Okay. And now 1, 0,
1, 0 is a 0.
0. They going down.
Then
0,
0,
0.
0,
No,
0, no change.
no change. And 0, 1, they go to
0, 1, go to
1.
1.
1.
Okay. They go to 1 up to here. Okay. 0, 0, no,
No change.
no change. 1, 0. Go to here.
0.
0, 0, no.
No change.
That's how the output look like. Only thing is you know how to looking into the truth table. Then you can draw the output. Okay, any question? Now, next one. Get SR lot. Now they adding two more gate, and they connect into that's what they call a enable. Okay. If enable equal 0, see what happened. If enable equal 0, what is output here?
It's 1.
1. And the output here.
It's 1.
1. Okay. And this is a NAND. If you get a 1 in here, 1 in here, what happened to Q?
It's going to be 0.
0.
Both of them 0.
Go back to NAND. This is a NAND. S equal 1, R equal 1. There will be no change. So Q and not Q, there will be no change. The thing is, this is a NAND. Okay? So 1 and 1, output will be no change, and that will be no change.
Mr. Pham, that configuration with it looks like an OR gate, but it's the input got the two bubbles. Yeah, so that makes it a NAND gate, right?
Exactly. Either way. Okay, sometimes they draw the NAND normally. Like you see this is NAND. However, this also the NAND, but they're using the OR gate.
So it's the output of a NAND going into the input of a NAND.
Right.
Okay.
So now that's only telling you. In this circuitry, if enable equal 0, doesn't matter input S or R. You want to change output cannot be changed. That's why output they say no change. So basically what they telling you, enable will be control this circuitry. Okay? If they want the output to be no changing, enable 0. You can change S here, you can change R here. However, output still be no change. And now, if you change, okay, enable equal 1. So what happened here?
0.
You can see S will be not S. Or with 1, not 1 will be
0.
right?
Yeah.
And same thing here. Okay. Not or 0 equal not up. So now if you get the enable equal to 1, so they just working and just like the NAND. That's it. The NAND flip-flop. Okay. So basically they're using enable to control output Q. If they don't want output Q to be changing, then enable equal 0. If enable equal 0, then you can add or R, that doesn't matter. Okay? Output still be no change. That's what they call a rated SR latch. Okay? You can try that one, okay? Right now, we don't have enough time. I need more time, okay? And this one also, what is it here? Get D last. Okay. D flip-flop, but again, now you can see this is the logic circuitry. This is the symbol. For this D gate, you get only one input, okay? And another one will be enable right here, okay? So exactly the same like the other one. They get enable right here. They get enable.
Mr. Pham, can I ask you a real quick question?
Yeah.
These circuits that you're showing us, like these latch gates and all of that, we could build these and then put like either a 1 or 0 on the input to see what the output is. Would that work?
Yeah. You can test only single circuitry.
Okay, we could do that on like a multi-sim 7 or something, right?
Right, exactly.
Okay, thank you.
Okay, so now this is a get D latch. They get only one input here and another enable. So now I can tell you same thing. Enable equal 0. What happened to Q? Not Q.
No change. No.
Will be no.
No change.
No change. No change. They're telling you Q equal 1, they still be 1. Not Q 0, they still be 0. Okay. Now, however, enable equal 1. So if you're looking into here, you can see D will be not D, right?
No D. Yeah. Load 0.
That will be D, not D, and not again. D. Okay. Or 0. So that's only telling you Q equal D if enable equal 1. Okay. If you get only one input, D can be equal 0 or D can be equal 1. However, if enable equal to 1, then Q equal D. D0, Q0, D1, Q1. But if enable equal 0, then Q will be no
change.
No change. Even you change D to 1 or 0 doesn't matter. Q have to be no change. That we call D latch. Okay, so I quickly explain to you on this one so you can do it. Next time we get a time we can review. Okay, they want to draw the output for D latch. And they also, they say, initially, output reset,
That means initially is at 0.
0. That means at the beginning, Q
Equals
equals
0.
0. Okay, now you can see this enable right here. 1, 0. Okay, so enable equal 1. What Q?
1.
1. Okay, Q equal D. Okay, Q equal D. That means enable equal to 1. Then now, okay, Q equal 1. 1 for how long? They must be 1 up here. Is that right?
No.
The thing is here when the enable equal 0, Q will be no change.
Not change. Yeah, it's true.
Okay, and when enable equal 1, Q equal D 0. So that's why they go to 0. Okay, and there will be no change here.
Yeah.
Okay, and that is 1 here, so they go 1.
The 1.
And there will be no change, right?
Not change. Yeah.
There will be no change up to here, and no change up to here, right? Okay, and you can draw for the rest. We get here. Next time, I will be talking about that. Now, I'm talking about the flip-flop. You can see that one we already learned. That's just a flip-flop, okay? And basically, you can read it, okay? I don't need to go through that thing. I will be go into the flip-flop. You can see same thing. This the first one they get a D flip-flop. This is a D flip-flop. This is a JK flip-flop. And this is a truth table for the D. That is a truth table for the JK. Okay. Only one thing.
One is positive clock and the other one's negative clock.
Yeah. This is see me the clock. Okay, now you can see. The clock will be look like this is the clock 0, 1. Okay, 1, 0 go to 1. That one. Okay, who know the name? What to call that one? That's what they call a leading edge.
Positive transition.
Exactly. Leading edge. That means clock going 0 to 1 transition.
And that's a positive clock, correct?
Right, positive clock. If the clock going this way, go
Negative.
down. They call a
Negative clock.
negative
Oh, well,
going.
that's the negative edge or whatever.
Negative going.
Negative going, okay.
Transition. Okay, so the clock will be working with either positive going or negative going.
Mhm.
If you're looking on the CD flip-flop, you see the clock have a no bubble. So for this guy, the clock will be going 0 to
1.
0 to 1. That means Q equal to D when the clock going 0 to 1. Without that transition, Q will be no change. And also for the JK, they get a bubble. So the transition will be 1 to 0. So that's why you can see right here. This is positive going. This is negative going. You want to apply to get the output Q and not Q for JK. Then you must get the negative going. In order to get the output you want it. For the D flip-flop, very simple, Q equal D. Only when the clock going 0 to 1. Question is, why they using transition? Why they not using clock equal 1 or clock equal 0? But they using the transition 0 to 1 or 1 to 0.
Maybe because sometimes you throw in there, you reset it or you set it or something, and then that means right then and there the output is going to be 0 or 1 no matter what. Maybe you change it.
That only telling you the transition 0 to 1 or 1 to 0. That very, very short time. Okay? So make sure the output Q cannot be changed no matter what. If you're using the level, for example, clock equal to 1 and Q equal to D. However, if the clock equal to 1 and they get a noise or they get something else, maybe can change Q output. They don't want. So that's why they're using transition. The transition take a very, very short time in order to make sure Q be stable. That's why they're using transition.
They want Q to stay the same.
Yeah. However, if you're working on a D flip-flop, you want Q equal to D, then you must be get a clock transition. Without that clock transition, Q will be no change. And the same thing apply for JK. Only transition will be positive to the negative. You're looking in the JK flip-flop. J0, K0, output no change. J0, 1, output 0, 1, and so on. Now, you just learning about set, reset, SR, flip-flop. They don't have any part in commercial. They get only the JK flip-flop in a commercial. That part, I believe, 74, 76. How come they don't have a part for set, reset, flip-flop we just learning? Okay, the reason is for JK, they can do whatever in the set and clear or set and reset, can do it. So that's why they don't need that in commercial. JK can do all of the job for the set and reset flip-flop. They can get no change, they can get toggle. Only thing here, maybe you not understand toggle. What does it mean toggle?
Oh, it was 1, but now it's 0, or it was 0 and now it's 1.
Exactly. Toggle mean if it was 0, then now they go to 1. If it was 1, now they go to 0. No change, you already know. Okay, so now you see this IC will be 74, 74. This is the IC. 1, 2, 3, 4, 5, 6, 7, 14. Same thing. 14 will be power. 5 volt. 7 will be rounded. How many flip-flop inside?
2,
You can see this here.
2.
Okay. 1 flip-flop, 2 flip-flop. And if you're looking in here, pin number 1 go to the clear input, pin number 2 go to the D, and so on. Okay.
3 goes to the clock.
Also, this is a JK flip-flop. Only the JK flip-flop you have to pay attention. Power. Power will be pin number 5. Not 16. They get a 16 pins. Round will be pin number 13. Okay. So if you get a wrong connection VCC, you cook the IC. This special. They get 16 pins. 1, 8, and up to 16. They're telling you what pin doing what. Okay. Pin 1J. Okay. Pin 16K. Inside the IC, you get 2 flip-flop. Okay.
Hey, Mr. Pham, what was that MS?
What?
Right there, it says dual JK, then it says M/S. What is that?
Dual.
No, the M/S. M/S. After the JK.
After JK here. J here. K here.
It says dual J/K.
A dual.
Yeah.
Dual, that means you get 2.
Yeah, no. What is the MS? What is the MS?
That will be no, I'm not, I don't know.
You don't know what that is?
Yeah.
Okay.
After
Gotta look at the data sheet, right?
Right. You're looking at a data sheet, they're telling you.
Okay, thank you.
That one will be explained later. Okay, that one will be explained later. What I want to talking about. Okay, this is the last one. Asynchronous, preset, and clear. So when you read it, okay, you will really understand what I want to telling you. One thing, you see on the flip-flop D, they get 1 input D. D, 1 clock input here. And now you get any flip-flop in the commercial. They get 2 input here. Okay. That means set SD. reset RD. Okay, now this is what they call a synchronous input. Okay, basically you can see, you're looking on this flip-flop here, you can get input D, input the clock, input SD, input RD. So basically they get two things. First thing, a synchronous, that means if set equals 0, Q must be 1, no matter what. Okay? If you get a 0 here, they don't care D, they don't care C input here. Q must be 1. And if you get a reset 0, Q must be 0. Okay, that will be telling you one thing.
S and
Never,
R, S and R can never not be 0 at the same time.
never S equals 0 and R equals 0 at same time.
Not allowed.
Okay, why? The thing is, you can say S equals 0, Q must be 1, R equals 0, Q must be 0. So when you set a 0 here and 0 here, flip-flop don't know what to do. Okay? So that's why we can say never S equals 0 and also R equals 0. If S equals 0, then R must be
1.
1. Or R equals 0, then S must be
1.
1. So now, if S equals 0, and you know Q must be 1,
Mhm.
and the clock or D can be 0, 1 doesn't matter. Clock can be going 0 to 1 doesn't matter. Q must be 1.
Mhm.
So when you testing, you want Q to be a 1, and you want set to be 0. So if something not right, when you troubleshooting, only thing you need to measure S, make sure they be 0. And make sure you measure R, they have to be a 1. But do not measure anything on D. Do not take anything on the clock. The thing is, don't care. Okay? So basically, set and R, a synchronous input, they control the flip-flop. Why we need that? The reason is you understand inside your computer. They run by the clock. Everything have to go with the clock. However, sometimes they want to set the output to be a 1 or output to be a 0 without the clock, and they have to either set or reset. Okay? So you get for normal operation, that means for the clock operation, then S and R must be 1. If you want Q equal D, when the clock going 0 to 1, guarantee S and R must be 1. Either at 0 clock cannot work it. That they basically apply for everything. Okay.
So S and R can be 1 at the same time, but they can never be 0 at the same time.
Exactly. Normally they will be 1 at the same time for the clock operation.
Correct.
Only thing is when you want to set output to be 1 or to be 0, then you need to set at either to be 0 or to be 0. That will be talking about the lab. I want to stop that one. I go to the lab. I want to share quickly talking about the lab. One lab I want to do it. Okay, just wait a minute. Let's see. I want to talk about this lab here. Just a minute. Okay. This is a JK. Okay, 4. I want 5. I don't want this 4 here. I want that to be 5. Easy to talking about that. How come? Okay. This is number 5. Okay, when you're looking into this circuitry here, how many IC?
4. 4 ICs I can see.
Okay, if you don't know, go ahead and ask it. Okay, in order to know how many IC, easy way, count by U1, U2, U3, U4, 4 IC. Okay, and you understand the U1, the flip-flop, the park will be 74, 74. U1A, U1B. The thing is inside one IC, you get two flip-flop. And U2A, that means another 74, 74, but you're using only one. Okay? So if you're looking into here, preset here, pin 4, connect to pin 10, connect to pin 4, and connect to PA pin 01. And I understand one thing. If preset 0, Q have to be 1. Q have to be 1. Q have to be 1. And now, this one also asynchronous via clear. Clear equal 0. Q must be 0. Q must be 0. Q must be 0. And now, for normal clock operation, what that mean? Q equal D when the clock going 0 to 1. Okay? So basically, they're telling you, draw using PSPI. Okay? And I given to you input here. P clock. Okay? And now preset 0 and going 1. Then they go 0 right here. Go back 1. And a clear 0 here. And then you can collect the data. Put it into the output P1, C, PC1, PC2, PC3. Okay? And in here, when you're reading, you try to answer the question. Okay? How many D flip-flop in one IC? I know that will be 2, right? And also this one, they're telling you to complete, fill it up here. I picked number 3. I gave it clear equal 1, preset equal 0. What D supposed to be? What the clock supposed to be? What Q supposed to be? This one, maybe you can answer for me. Number 3.
Number 3. Pre is 0, so Q got to be 1.
Right here, Q have to be
1.
1. Now, the input D.
Don't care.
Don't care. You see that? Enter 0, 1, X, P clock, and clock. So the thing is preset equal 0. You don't care about D. How about the clock?
If it's a D flip-flop, it's, well, you really don't care because it's mandatory that it's 1 if pre equals 0, then the output must be 1 no matter what. So you really don't care about that either.
Correct. The thing I already said, preset equal 0, Q must be 1. You don't care about D. You don't care about the clock. So that's why you have to don't care. When you enter a right one, that means you understand. Now, on that one, clear 0. And you know output must be
0.
Must be 0. And the input the same thing, right?
Don't care.
Clock will be down.
Don't care.
Don't care. Now, number 5. Clear equal 1. Preset equal 1. That's normal, right?
Clock operation.
Clock operation. So D equal 0, you get positive clock. What output?
Let me see. You got 1, 1. You got D. Oh, it must be, it's got to be D.
What logic?
D is 0.
0. Right? D equal 0. If you get a party going, clock Q equal D, 0. If D equal to 1, P clock, then Q equal
1.
1. That one here. Who can telling me? Now you get negative clock.
Well, is this what D flip flop, right?
It won't change, so it's still be 1.
Perfect.
One.
Perfect. Clock must be positive going.
Right.
Negative going, they not
Don't apply.
apply for key week 1D. So there will be no change.
No change.
No change mean it was 1 now, they still be
1.
1. You see that? Okay. After you get it done, you complete data here. You cannot enter anything here. The reason is, but it's not affected, okay? They keep whatever over here. And now you need to change something in here, depending on your simulation. And you can get into the output Q, okay, 0, 1, 2. Okay. And that coming from here. After you get this one, path, copy that into port A, B, C right here. Okay. And then after you get path, you write your program. Okay. And put it here. Upload it. So Sam will take that. Okay. On the left number 3, I already gave it to you part of the test program for the flip-flop. If you're doing number 3, then you know how to apply P clock or N clock. One apply for positive going, another apply for negative going. Okay. So up to this point, any question?
I just have a question on, I try to do that test, number 15 doesn't seem to be coming through properly on test clock 12. I got 0, 0, 0, but and all the other tests seem to be right, but I can't get a positive on it, so.
You're talking about what lab?
Right there on row 71.
Oh, this lab, right?
Yeah, row 71. It should be 0, 0, 0 according to my output, but it's not passing for some reason. That seems to be the only line.
Okay, so basically in here, okay, you can see preset here. Then the output supposed to be 1. Okay, clear. That means at this area, Q have to be 0.
Yeah,
Okay.
I'll talk to Sam when I get into the lab. It was specifically on that test number 15. I just every test 1 through 14 seem to work.
Did you check your pre-test further down? I think it's on number 8 or number 9.
Yeah. Yeah, the first 14 worked. For some reason, the Excel spreadsheet on 15 seems off, but I'll check it when I go in the lab on Tuesday.
Okay.
So don't worry about it. Thank you.
Yeah, depending on you run simulation, how far you go. On this one, I'm not giving to you the time, right? But you can see you get a 15 test. This is only test number 12. Okay. And basically, each one they need a 2 microseconds. So basically, you have to set around 30 microseconds or 28 microseconds. So they can go through on of the test. Okay. Okay, you must be running simulation. Okay, any question to me? Okay, if it's not, so good night.
Good night, Mr. Pham. Have a good weekend.
Thank you.
Nine.
Good night.
Good night.
Good night.